In this video, we are going to look at one more type of question involving change in momentum, and we need to find the force in this case as well. The question is like this, that we got this wall here, and there's an object here, call it a ball or an object of mass 500 grams. It is going towards the ball with a speed of 36 meters per second, and it hits the ball here and then rebounds back with the same speed, 36 meters per second. And the ball is in contact with the wall for 0.2 seconds. So in 0.2 seconds, the ball's velocity has changed. So it means some force must have been applied on the ball. And in this particular case, the force is applied by this wall. And vice in the other direction as well, the ball is when the ball experiences this force, the wall also experiences force, or in other words, the ball forces the wall as well. And these two forces, like action and reaction, are equal. So a question that sometime you get would ask you to find the force applied by the ball on the wall or applied by the wall on the ball, which basically are same. So let's look at this question. We will be solving this question by considering change in momentum. So we are going to use this equation F is equals to delta P over T. All right, so we need to find delta P, we need to find P initial and P final. So P initial is initial momentum, which is equals to mass times velocity, 0.5 times 36, which is equals to 18 Newton second, and it got a direction like this. I'm just showing without any angle here. And P final will be same because magnitude of the velocity is same and mass is same, so it will also be 18 Newton second, and that is in this direction. Now we need to find delta P, which basically is finding PF and minus PI. And just like the previous example, I will write this equation as PF plus minus of PI. Now let's draw these three vectors. I will draw PI, then I will draw minus PI, and then I will draw PF. So PF, PI is the wall here is my reference, so I will show the wall with dotted line, and I will show my vector with an angle from that wall. So PI is, if you look at this is my wall, and PI is, I need more room here. So this is my PI. We'll draw bigger diagram. This is my PI, and that is my vector, and that angle is 40 degree. So minus PI is same vector here, but only the direction is different. So minus PI is going like this, and that angle is 40 degrees. Simple. And likewise, I will draw PF as well. So PF is equals to, again I will show my wall here, that's my reference for direction, and my PF is going like this, and that angle is 40 degrees. Now in all these cases, the length of the vector is 18 here, the length of the vector is 18 here, and the length of the vector is 18 here. Now to find delta P, I need to add this vector PF and minus of PI. I need to add these two vectors. So let me do a geometrical construction here. So again, I will start with my first wall here. That's my first wall here, and I will draw PF here. So PF is going from here like this. The length is 18, that angle is 14. Now from here I need to draw the other vectors, the second one, which is minus pi here. So it will go like this. But again, I need to, for my reference, I need to draw the wall here, and from this wall I got that's my another length is 18, and this angle is again 40 degree. And because that was the starting point and that's the final point, so this is my vector delta p that I need to find. Yeah, I mean it's a bit messy here. So what happened here? Just let me draw it again like this, and then I hope it will suffice. All right, so this is my delta p I need to find. Sorry, that's my first vector and that's my second vector. I hope it makes sense. Okay, so and the length is 18 in both the cases, and this is delta p that I need to find. Now this is an isosceles triangle because this length of the triangle is 18, that length of the triangle is 18, so it's an isosceles triangle. And further, this angle is 40 degree, so that angle will also be 40 degree because they are alternate angles between two parallel lines. This vertical wall and that vertical wall, they are parallel. So this angle is 40, that angle is 40, and it's an isosceles triangle, which means that that angle and that angle will be equal because it's an isosceles triangle. That side of the triangle is equal to that side. So 40 degree here, 40 degree here, which makes it 80. So remaining these two angles, this and that, they are together equal to 100 degrees. And because they are equal, so each of these will be 50 degrees. So that angle is 50 degree. Let me write it 18 here so that I get 50 degree here. Now when we look at this angle is 40, that angle is 50, which means this angle is 90 degree, which means my delta p is perpendicular to the wall. Now only we need to find now is the length of this vector delta p. I can give these names, so let me call this point O, that point A, that point B. Now from O, which is the vertex of isosceles triangle, I drop a perpendicular here. Yes, the line is already there, I'm just extending it, and let's call it N. So let me clean this here and let me call this N. Delta P is this length here from here to here. Now because it is isosceles triangle and I have dropped the perpendicular, it's the property of the isosceles triangle that any perpendicular dropped from the vertex O onto the opposite side will divide the opposite side into equal parts. So what it means is that AN is equals to NB. So if we are to find delta P, all we need to do is we need to find either AN or BN, and we need to double it. All right. So let's look in this triangle. Let me draw this. Let me go to the next column here. So in triangle OAN, I can find sine 40 here. Sine 40 degree is equals to AN over 18, opposite over hypotenuse, and that gives me AN is equals to 18 sine 40, and that I just plug in the calculator, I get 11.57. That's the length of AN, and therefore length delta P is equals to 2 times 11.57, which basically is 23.14 Newton seconds. That is the magnitude of delta P, and we can associate direction as well. So I will write delta P as a vector as 23.14 Newton second, and the direction is, I'll write perpendicular to wall. Whenever you are mentioning direction, take care that your direction is always from a given reference. And here, my reference is the wall. I got delta P. Now finding F is easy. Delta P over T, which is equal to 23.14 Newton second, perpendicular to wall. I'll not write the direction here, just write at the end, divided by 0.2, and that gives me 117.1 Newton. Taking the direction into account, I'll say perpendicular to wall. So that is the force that would be exerted by the ball on the wall or by the wall on the ball. Either ways, because action and reaction are always equal. If ball is applying that much force on the wall, then wall is also applying that much force on the ball.